Alright, ladies and gentlemen, we have a few practice problems set up here using this simulator. What you see in front of you is you see the cannon is elevated to the 10-meter mark. We will then use the 10 meters high and the initial speed here of 20 meters per second to make a prediction as to where the cannonball will land. How far is this target over here at the corner of the screen? Doing that, you need to do a couple calculations. How this is going to work is I will simply pause my recording and I'll let you work it out, and then I will work it out after I give you that time to do it, and you'll see if you are right. So go ahead and, using the 10 meters high and 20 meters initial velocity, predict the landing point of our pumpkin. Go. Alright, hopefully you have then calculated how to get the time. So using the given height of 10 equals 1/2 of 9.81 meters per square second times t squared. I forgot to put my negative in, so make sure you're doing that with your calculation here. So a negative thrown in. We're going to put in negative 10 in for there, and I'm sorry if this is sloppy. I'm using the mouse, not the pen. Equals negative 4.905. That's in meters. This is meters per square second times t squared. So we'd have to divide our 4.905 over, so when I grab the calculator and do a quick calculation, if we say the negatives cancel then when we divide that, so 10 divided by 4.905, enter. We're getting 2.038 as our t squared. So then we have to square root that to get our time. Square rooting. We are going to take 1.427 seconds to reach our destination. Now, the next calculation is, of course, to figure out where it will land. If we have an initial velocity of 20, we need to use the next equation to calculate that. I'll give you a second to do that in case you haven't. Alright, so here's your equation. We're going to put in our 1.43 seconds for time times our 20 meters per second for velocity to find our predicted value. Our predicted value would therefore be, hopefully you have this on your paper, 20 meters per second, or I'm sorry, times 20. And I got 28.55 as my predicted value. And if I get my tape measure here and I measure this out to be 28.55-ish, and I fire, let's see if I hit the target. Score, we did it. We hit the target. Excellent. Good practice number 1. So I'm going to erase that, and I'm going to change the setup. Alright, next problem. We are now doing a little different here. I've got the cannon at 15 meters high. How fast must the cannon shoot in order to hit the target here at, it's 20 meters. The target's at 20 meters. How fast must the cannon shoot in order to do this? I'll give you a few minutes to work on that. How fast must the cannon shoot to hit 20 meters away from a height of 15 meters? So it's 15 meters high, the target's 20 meters away. How fast? We're going to change the velocity here to figure that out. Calculate that in case you didn't get that. Alright, so you must be ready to start calculating it. So let's look here. Got my calculator out, clear out the last problem. So to find out how to get this there, we need to find velocity. So to find velocity, knowing that this is 20 meters, we need time. 2 variables, can't do this one first. So we got to find time using this one. So let's go, let's see, where's my negative at? Negative 15 meters, negative 15, because it's going to fall 15 meters, divided by negative, I don't know what that's doing, 4.905 negative, aha, 15 divided by 4.905, which is half of 9.81, equals 3.058, and then that equals t squared. So we need to then square root that and get our time. Our time is 1.75 seconds, we can say. Now, 1.75 seconds here equals 20 meters over here with the v in the middle. We need to divide that time over, so 20 divided by that. 20 divided by 1.75. 20 divided by 1 point, oh no. 20 divided by 1.75, and our predicted distance would be, or our predicted velocity should be 11.42. So if I put that in here, let's see how detailed it lets me go. 11.42 for our initial speed. In theory, it's going to hit it. Instead of a pumpkin, let's shoot a Buick. Hey, it hit. Excellent. Next problem. Next problem. Now, our target is at 15 meters. We're going to shoot our shot at 15 meters per second. Given these two things, the horizontal distance and the initial velocity, how high up must our cannon be in order to strike the target at that location? So there's your calculation. You need to figure out how high up. I'll give you a second to do those calculations. How high up? Go. All right, so how high up? We want to find delta y. We need time to find delta y. Well, we also need time here. We don't have it. What we have is 15 meters for delta x and 15 meters per second velocity. So if I pull up my calculator and I divide 15 by 15, 15 divided by 15 with a time of 1 second. Excellent. So we put in our time of 1 second. 1 second here, let's square it. 1 second times 1 second. That equals 1 times 9.81 times 0.5. Ha! Our height must be 4.905 meters. So let's set up the cannon at 4.9. 4.9. Good enough. 4.905. Bring the cannon down to level right there. And let's see if we hit our target. Ah, wonderful. He hit the target. That is all of the practice problems.